In question 11, the point P3, 5 lies on the curve y equals to 1 upon x minus 1 minus 9 upon x minus 5. In part 1, we have to find the x coordinate of the point where the normal to the curve at P intersects the x-axis. Now, to find the x coordinate of the point where the normal crosses the x-axis, we first need the equation of the normal, and then we can substitute y equals to 0 to find the x coordinate. Now, to find the equation of the normal, we need the gradient in the first case. So, to find the gradient, first we'll find the dy dx of the function. We'll first write it as x minus 1 to the power minus 1 minus 9, and this will become x minus 5 to the power minus 1. Finding the gradient dy dx, which will give us the gradient of the tangent. So minus 1 will multiply with the coefficient. So this will become minus x minus 1 to the power minus 2. Minus 1 into minus 9 is a plus 9, and this will become x minus 5 to the power minus 2. We can simplify it and write it as minus 1 upon x minus 1 whole squared plus 9 upon x minus 5 whole squared. Now, as the point P has x coordinate 3, we can substitute x equals to 3 up here. So this will become minus 1 upon 3 minus 1 whole squared plus 9 upon 3 minus 5 whole squared. Simplifying this, this will become minus 1 upon 2 squared, which is 4, plus 9 upon 3 minus 5 whole squared, which will be 4. So minus 1 plus 9 is 8, 8 upon 4. So the gradient will be 2. So the gradient of the tangent is 2, which means that the gradient of the normal will be a negative reciprocal, which is minus 1 upon 2. Once we have the gradient and we know that the normal passes through the point 3, 5. So the point is P, which is 3, 5. We can now make the equation using y minus y1. So y1 will be 5 equals to m, which is minus 1 upon 2 into x minus x1, which is 3. Now to find the x coordinate at where the normal crosses the x-axis. So we know at the x-axis, the y coordinate will be 0. So we'll substitute y equals to 0 into the equation. We'll get 0 minus 5 is equals to minus 1 upon 2x plus 3 upon 2, multiplying half with x and minus 3. Simplifying, we'll get minus 5 minus 3 upon 2 is equals to negative 1 upon 2x. Taking the LCM, this will become minus 10 minus 3 upon 2 is equals to negative 1 upon 2x. This will become minus 13 upon 2 is equals to negative 1 upon 2x. The negatives will cancel and the 2 and 2 will cancel. So the x coordinate will be equals to 13. In part 2, it says find the x coordinate of each of the stationary point on the curve and determine the nature of each stationary point, justifying your answer. So for stationary points, we'll have to put the dy dx equals to 0 and then find the values of x. So the dy dx is minus 1 upon x minus 1 whole squared. So in the first step, we'll write it as dy dx is equals to minus, which is x minus bracket x minus 1 to the power minus 2 and plus 9 into x minus 5 to the power minus 2. So this is plus 9 into x minus 5 to the power minus 2. Putting it equals to 0, we'll get 0 is equals to minus x minus 1 to the power minus 2 plus 9 into x minus 5 to the power minus 2. Taking x minus 1 to the power minus 2 on the left hand side, this will become x minus 1 to the power minus 2 plus, which is equals to 9 into x minus 5 to the power minus 2. We can now bring this in the denominator and write it as 1 upon x minus 1 whole squared, and this is equals to 9 upon x minus 5 whole squared. To get rid of the squares, we can directly square root both the sides. So we'll get 1 upon x minus 1, and this will be 3 upon x minus 5. Now, as a square root can contain both a positive or negative value, so we can include a positive negative sign with one of the sides. So let's say we can take plus, x minus 1 as a plus minus. We can do the same with x minus 5. It will give us the same answer. So to find the first value of x, we can take it as 1 upon x minus 1 is equals to 3 upon x minus 5. And for the second value of x, we can take it as minus 1 upon negative x minus 1, which is equals to 3 upon x minus 5. Cross multiplying, we'll get x minus 5 is equals to 3x minus 1. Taking the x on this side, we'll get minus 5 plus 1 is equals to 3x minus x. So minus 5 plus 1 is a minus 4, and this will become 3x. So this will become minus 5 plus 3x minus x, which is 2x. So x will be equals to minus 2. And there was already a negative sign over here, which I missed. So this would multiply. So there is a small correction that needs to be done over here, as there was a negative sign already over here. So this will become 1 upon x minus 1, and this is 3 upon x minus 5. Cross multiplying it with 1, this will be 3x minus 3 is equals to x minus 5. So 3x minus x will become a 2x, and this will be minus 5 plus 3. So the value of x will be 2x is equals to minus 2, and x will be equals to minus 1. And then this will become minus x plus 1. So we can write it as minus x plus 1 is equals to 3 upon x minus 5. Cross multiplying, we'll get x minus 5 is equals to minus 3x plus 3. Now taking 3x on this side, we'll get x plus 3x is equals to 3 plus 5. So 4x will be equals to 8, and x will be equals to 2. So the two values of x are x equals to 2 and x equals to minus 1. Now, as we will also have to find the nature of each of the stationary points, so we'll first have to find the double derivative. Finding the double derivative, we'll have to differentiate the function for dy dx again. Now, the function for dy dx was minus x minus 1 whole squared to the power minus 2, and this was a plus 9 into x minus 5 to the power minus 2. Now, differentiating it again, we'll get, so minus 2 will multiply by minus 1, that will become a plus 2 into x minus 1 to the power minus 3. Minus 2 into 9 will become a minus 18, and this will be x minus 5. Minus 2 minus 1 will be minus 3. So the expression for d square y upon dx square is 2 into x minus 1 to the power minus 3, which we can now write it as 2 upon x minus 1 whole cube minus 18 upon x minus 5 whole cube. Now to find the nature, we'll substitute the two values of x individually, taking x equals to minus 1. So when x is equals to minus 1, this will be 2 upon minus 1 whole cube minus 18 upon, so the value of x was minus 1, so this will become minus 1 minus 6 whole cube. So this will be equals to 2 upon minus 2 whole cube, which is minus 8, and this will be minus 18 upon, so this will become minus 6 whole cube. So minus 6 whole cube will be a minus 216, or we can write it as minus 1 upon 4 plus 18 upon 216. So 18 divided by 216 plus, so and subtracting it from 0.25, we'll get a negative 0.176. Now, as it is a negative value, so as we are getting negative 0.176, this means that when x is equals to minus 1, as this is less than 0, this will be a maximum point. And now substituting x equals to 2 into the same expression, we'll get, so when x is equals to 2, so this will be 2 upon 2 minus 1 whole cube minus 18 upon 2 minus 5 whole cube. So this will be 2 upon 1 cube, which will be 2, and this will be 18 upon minus 3 whole cube, which will be minus 27, and this negative will make it a plus. So this will become 2 plus 18 upon 27. Now, as this value will be greater than 0, so we can say that when x is equals to 2, it will be a minimum point.